Hi, my name is Ashley Geike. I'm doing my capstone project on the Great Smoky Mountains and the effects of air pollution and the air quality. Here's a map of the Great Smoky Mountains National Park. Um, the Great Smoky Mountains, air pollution is a large problem there. The Great Smoky Mountain National Park in the southeast wasn't named for its smog, but it is one of many parks seriously affected by the problem. Air quality issues originate outside the parks. At Great Smoky, power plant and industrial emissions are blown by winds to the southern Appalachians and trapped there by the mountains. Air quality problems choke off views, poison plants, and even foul water. Recent air quality data show a glimmer of hope. Visibility and ozone concentration are stable or improving in most parks. However, in too many cases, stable means simply preserving a subpar status quo. So continuing with air pollution is shrinking the scenic views. So when you're going to the park, sometimes you're not even able to see all the way through to the different mountains because of the smog. It's damaging plants and degrading high elevation streams and soils in the Great Smoky Mountains. Even human health is at risk. Most pollution originates outside the park and is created by power plants, industries, and automobiles. Wind currents moving toward the southern Appalachians transport pollutants from urban areas, industrial sites, and power plants located both near and far. The height and physical structure of the mountains, combined with predominant weather patterns, tend to trap and concentrate human-made pollutants in and around the national park. So this picture over on the side just shows different things that cause the pollution, where the pollution goes, and then once it travels and gets stuck into the mountains, it kind of just settles in there and has nowhere to go from side to side. The effects of air pollution, the further impacts on the park of 10 million human visits each year are only just beginning to be measured and mitigated. Scientists are striving to better understand these impacts on the park's ecosystem. Park staff carefully monitor threats such as air pollution and destructive non-native species and endeavor to implement proactive measures to preserve the park's valuable resources. Ozone pollution. So another air quality problem is ozone pollution. This threatens human health and park plants. Not to be confused with the naturally occurring beneficial ozone layer, which filters the sun's ultraviolet rays. Ground-level ozone is a colorless gas created when nitrogen oxides mix with hydrocarbons in the presence of sunlight. Power plants, automobiles, and factories are the main producers of nitrogen oxides. Most ozone pollution originates outside the park and travels to the Smokies on prevailing winds. The ozone pollution is a powerful respiratory irritant for humans. Research shows that ozone can cause coughing, sinus inflammation, chest pains, scratchy throat, even permanent damage to the lung tissue and reduced immune system functions. Children, the elderly, people with existing health problems, and active adults are most vulnerable. All right, so then there was a mandate for clean air that was passed by the Congress in 1970, establishing a national policy for preserving, protecting, and enhancing air quality. The 1977 amendments designated all national parks that exceed 6,000 acres as mandatory Class 1 areas worthy of the greatest degree of air quality protection under the Act. Also under the Act, Congress mandates the federal land manager to protect air quality related values, including visibility, flora, fauna, surface water, ecosystems, and historic resources. It further directs the land manager to assume an aggressive role in protecting the air quality values of land areas under his jurisdiction. In cases of doubt, the land manager should err on the side of protecting the air quality related values for future generations. Under the Clean Air Act, the National Park Service is invited to comment on state air quality permit applications for major factories, power plants, and other air pollution sources produced for location near Class 1 areas. Since 1980, the Park Service has sent comments to nearby state and local agencies on over 24 permit applicants covering new pollution sources near the park. The Park Service has worked with state authorities to try to ensure that any increases in pollution be offset by reductions in pollutant output elsewhere, and that the best available control technology be used to minimize the amount of new pollution produced. The National Parks stand on air pollution and the Clean Air Act. The Park Service is working with state regulatory agencies, the Environmental Protection Agency, and industrial and utility interests to develop a comprehensive plan to prevent future damage through such measures as offset programs, the use of improved technology and determination of emission caps and government standards for various pollutants. To remedy air pollution problems at the park, additional reductions of nitrogen oxides and sulfur dioxide are necessary. So the geology of the Great Smoky Mountains, the rock is metamorphosed. Sedimentary rocks are the dominant rock types in this park, but some indigenous rocks also occur. Sedimentary rocks form from a cycle of erosion and deposition mostly in the water. The eroded materials include cobbles, pebbles, sand, silt, and clay, or the accumulations of shells from ancient sea animals. Igneous rocks solidify from the melted rock or lava. Plate tectonics. The Earth's outer crust is composed of huge continental-sized plates driven by heat from below that continually shift position. These moving plates grind past one another, collide into one another, and sometimes override one another. Also, where plate margins are separating or spreading apart, molten rock forces its way to the surface, solidifies, and forms new crust. So the mountain building between about 310 and 245 million years ago, the eastern edge of the North American tectonic plate collided with the African tectonic plate, becoming part of the supercontinent known as Pangaea. Continental collisions take place at a rate of a few inches per year over many millions of years and are a result of continuing global scale plate tectonics. So in this image here, one shows the metamorphic rock, and then the other shows the rising of the Appalachian Mountains where the continental collision occurred. And then here's my references.